Good morning class. Today we discuss electrochemical cell. Student, electrochemical cell is a device in which chemical energy in a redox reaction converted into electrical energy. I repeat, electrochemical cell is a device in which chemical energy in a redox reaction converted into electrical energy. For example, Daniel cell. Now, let us discuss the difference between the electrochemical cell and electrolytic cell as discussed earlier. Now, let us consider in electrochemical cell, chemical energy converted into electrical energy, but in electrolytic cell, electric energy converted into chemical energy. In electrochemical cell, anode is negative, cathode is positive, but in electrolytic cell, anode is positive and cathode is negative. In electrochemical cell, salt bridge is required, but in electrolytic cell, no salt bridge is required. In electrochemical cell, two different electrolyte taken into different chambers, but in electrolytic cell only one electrolyte is required. So the main difference between the electrochemical and electrolytic cell is that in electrochemical cell chemical energy converted into electrical energy, but in electrolytic cell electric energy converted into chemical energy. Now let us represent electrochemical cell. Suppose here we have a two vessels in which the first vessel contain zinc sulfate solution and the second vessel contain copper sulfate solution. Both vessels are connected through this U-tube containing salt bridge, and the electrodes are dipped in a this U-tube is called salt bridge. The main function of salt bridge is to complete the circuit and is to maintain electrical neutrality. Also, salt bridge provide path for flowing ions. Now, it is a negative terminal in electrochemical cell, that is called anode. It is a positive terminal in electrochemical cell called cathode. Here one thing must be noted. In electrochemical cell, oxidation take place at anode, but in electrolytic cell, oxidation take place at cathode. Now, it's a zinc sulfate solution. It's a copper sulfate solution. So it is the simplest way by which we can represent electrochemical cell, or we can represent electrochemical cell in a very simple method like this way. These two parallel lines indicate salt bridge. Your left hand side terminal is called anode. It is negative terminal at which oxidation take place. Right hand terminal is called cathode. It is positive terminal in which reduction take place. The flow of electricity is from cathode to anode. It is the simplest way by which we represent electrochemical cell. It should be noted salt bridge is generally made up of inert electrolyte like KCl, KNO3, etc. whose ions not participate in cell reactions. Now let us discuss electrode potential. Now let us discuss electrode potential. It is represented by capital E. The potential difference developed between the electrode and electrolyte. I repeat, the potential difference developed between the electrode and the electrolyte is called electrode potential. It is measured in volts. When the concentration of all species in half cell reaction is unity, electrode potential is said to be standard electrode potential. I repeat again, when concentration of all species involved in half cell reaction is unity, then electrode potential is said to be standard electrode potential. It is represented by letter E naught and its unit is volt. It should be noted the absolute value of electrode potential cannot be determined because oxidation half reaction and reduction half reaction cannot take place alone. Therefore, the special reference electrode is called standard electrode potential or normal hydrogen electrode. Its value is 0.0 volts. Now, let us discuss cell potential. Cell potential is defined as the potential difference developed between two electrodes. I repeat again, cell potential is defined as the potential difference between two electrodes. When no current is withdrawn from it, it is said to be electromotive force or EMF of cell. Here, one thing must be noted, EMF of cell is the maximum voltage obtained from the cell. The main difference between the electrode potential and cell potential is that electrode potential is the potential difference between the electrode and electrolyte, while the cell potential is a potential difference between two electrodes. Now, let us discuss Nernst equation. Student, Nernst equation is very helpful for solving numerical given in exercise. Let us discuss Nernst equation. According to Nernst equation, E cell is equals to E naught cell minus 0.0591 upon n log base 10 concentration of oxidation by concentration of reduction. It is a Nernst equation by which we can solve numerical given in NCERT. Here one thing must be noted, temperature is 298 Kelvin and pressure is 1 atm. Now in NCERT, Nernst equation is represented like this manner. Suppose there is a cell reaction in which Mn positive aqueous on gaining an electron converted into M solid. So the Nernst equation of this reaction is represented as E cell is equals to E naught cell minus 0.0591 upon n log base 10 1 upon concentration of Mn positive. Why we taking 1 here? Because the concentration of your solid and liquid taken to be 1. So it is the way by which we calculate EMF of cell. Now there is a relationship between E naught cell and standard Gibbs free energy. The relationship between standard Gibbs free energy and E naught cell is delta G naught is equals to minus NF E naught cell. Here N is the number of electron loss or gain, F is a Faraday constant whose value 96500, E naught cell is the cell potential. Now there is a relationship between E naught cell and equilibrium constant. It is E naught cell is equals to 0.0591 upon n log base 10 Kc. Here Kc is the equilibrium constant. N is the number of electron loss or gain. Now let us review further. Next equation is E cell is equals to E naught cell minus 0.0591 upon n log base 10 oxidation upon reduction. Here the value of E naught cell we can calculate with the help of formula. E naught cell is equals to E naught reduction minus E naught oxidation. I repeat again, E naught cell is the EMF of cell or cell potential. It is calculated by subtracting electrode potential of oxidation from electrode potential of reduction, or you can write like this manner also. E naught cell is equals to E naught reduction minus E naught oxidation. It should be noted the reaction is feasible only if the value of E naught cell comes out to be positive. If the value of E naught cell comes out to be positive, then reaction is feasible. if the value of E naught cell comes out to be negative, then the reaction is non-feasible. There is a relationship between the E naught cell and the standard Gibbs free energy. It is delta G naught is equals to minus NF E naught cell. There is a relationship between E naught cell and Kc. It is E naught cell is equals to 0.0591 upon N. N is the number of electron loss or gain, log base 10 Kc. Now let us discuss numerical based on these formula. Suppose it is NCERT question number 3.5 in which it is given calculate EMF of cell and write Nernst equation for following cell reaction at 298 Kelvin. Now let us discuss numerical based on this topic. Suppose we have to write Nernst equation and represent the following cell according to Nernst equation. Mg solid slash Mg double positive 0.001 capital M, salt bridge is there. Cu double positive 0.0001 capital M slash Cu solid. The value of reduction potential is given Mg double positive slash Mg minus 2.36 volt and E naught value of Cu double positive slash Cu, that is reduction potential of copper, is given 0.34 volt. Our first aim is to write this cell into a reaction, that is Mg is oxidized while copper is reduced. So write Mg solid plus Cu double positive 0.0001 capital M gives Mg double positive 0.001 capital M plus Cu solid. From this equation it is clear that magnesium is oxidized and copper is reduced. Now first we calculate E naught cell. E naught cell is calculated with the help of formula E naught reduction minus E naught oxidation. Here one thing must be noted, here reduction of copper take place, so its reduction potential is 0.34 volt, and oxidation of magnesium take place, its value is minus 2.36 volt. On solving this we get 2.70 volt. The value of E naught cell comes out to be 2.70 volt, which is positive. Then the reaction is feasible. Since E naught cell is positive, reaction is feasible. Now apply Nernst equation. According to Nernst equation, E cell is equals to E naught cell minus 0.0591 upon N log base 10 concentration of oxidation by concentration of reduction. It's a Nernst equation. Now substitute the values. Now substituting the value, E cell is equals to E naught cell value we earlier calculated, it is 2.70 volts minus 0.0591 N is the number of electron loss or gain, log base 10, take as it is, concentration of oxidation of magnesium take place whose concentration is 0.001 and reduction concentration is 0.001 take place, removing point increasing 0. Now we have 2.70. Here the value of N is 2 because 2 electrons are losing or gaining. The value of this comes out to be log base 10. Now we have 2.70 minus 0.0295 into 1 because log base 10 value is 1. Now on solving we get the value of E cell in volts. The accurate answer comes out to be 2.6708 volt. So first we represent cell into equation form, then calculate E naught cell by formula E naught reduction minus E naught oxidation. If E naught cell is positive, then reaction is feasible. Apply Nernst equation, putting the value of N E naught cell, concentration of oxidation and reduction. Then by solving we can easily calculate the value of E cell. Thank you very much.